Unit 3, pages 81 to 85, Rules for Differentiation, Finding the Derivative of a Quotient of Two Functions. So first thing we want to do is rewrite the function f of x as a function in polynomial form, and then use product rule to find the derivative. Okay, so I want you to do that part on your own. And I'm going to show you the rule for how to differentiate this when you have a quotient of two functions. So just as Leibniz was the first to publish a proof of the product rule of differentiation, Isaac Newton was the first to publish a proof for the quotient rule of differentiation using the limit definition of the derivative. So let's write this rule together in the box below. So the quotient rule of differentiation states that if I have a function h of x and it's equal to f of x over g of x, then h prime of x equal to the bottom function, which is g of x, times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Okay, another way that people remember this is they identify the top function as the high function, right? The top, high. And they identify the bottom function as low, or some people, just to keep the same consonant, will call it ho. Yes, I know, it's kind of funny. Okay, and then to remember the way that the setup goes, it's ho, d high, minus high, d ho, all over ho squared, or ho ho. All right, so to show that this rule works, we're going to apply this rule to the function that you did above, 2x cubed minus 3x squared plus 2 over x squared. Okay, so we're going to have this top function. We're going to call it our high. So this is our high. X squared is our ho. And we are going to rewrite this so that f prime of x equals our ho, which is x squared, the derivative of our high function, so 6x squared minus 6x minus our high function, which is 2x cubed minus 3x squared plus 2 times the derivative of our whole function, which is just going to be 2x all over 2x squared. Oh, sorry, not 2x. X squared squared. Sorry about that. X squared squared. So then simplify this out. We get 6x to the fourth minus 6x cubed minus 4x to the fourth minus 6x to the third plus 4x all over x to the fourth, which equals, when we distribute the negative sign, we get 6x to the fourth minus 6x cubed minus 4x to the fourth is 6x cubed minus 4x all over x to the fourth, which we can simplify to being 2x to the fourth minus 4x all over x to the fourth. Continuously simplify by taking out an x value from the numerator. We get 2x cubed minus 4 over x to the fourth, which we get 2x cubed minus 4 over x cubed. All right, so now what we're going to do is find an equation of a tangent line drawn to the graph of g of x being 2x minus 1 over x plus 3 when x is equal to negative 2. So here our high function is 2x minus 1. Our whole function is x plus 3. So g prime of x is going to be equal to OD high. So we get x plus 3, derivative of our half function, which is just 2, minus high d ho. So 2x minus 1, derivative of our whole function, which will be 1, all over ho ho or ho squared. That'll be 2x plus 6 minus 2x plus 1 over x plus 3 squared. It's going to be equal to 7 over x plus 3 squared. So to find the SOT for this, we will need to do g prime of negative 2, which is equal to 7 over negative 2 plus 3 squared, which will just be 7. And then our POT, we need g of negative 2, which would be 2 times negative 2 minus 1 over negative 2, 3, which will give us negative 5. So POT is negative 2 comma negative 5. So our final equation is y plus 5 equals 7. All right, now we want to use the quotient rule to prove that if f of x is equal to this, then f prime of x must equal negative 3 over x minus 1 squared. So we'll use our quotient rule. This value here is our high function at the top. Value on the bottom is our whole function. So f prime of x equal to OD high, which is x squared minus 1, 2x plus 3, minus high d ho, so x squared plus 3x plus 2 times 2x all over whole squared. So x squared minus 1 squared. And when we simplify the numerator here, we'll get 2x cubed plus 3x squared minus 2x minus 3 minus 2x cubed plus 6x squared plus 4x all over x squared minus 1 squared. And again, distribute that negative sign, 2x cubed plus 3x squared minus 2x minus 3 minus 2x cubed minus 6x squared minus 4x all over x squared minus 1 squared. And once we cancel some things out and combine our like terms, our 2x cubes will cancel out. Our 3x squared minus 6x squared will be negative 3x squared. And our negative 2x minus 4x will be negative 6x, and then our minus 3 all over x squared minus 1 squared. All right, and then from here, we can factor out a negative 3 from the numerator. We get x squared plus 2x plus 1 squared minus 2 x squared minus 1. Squared minus 1 squared. All right, and then we can factor some things out. So in the numerator, we have negative 3x plus 1 times x plus 1. And down at the bottom, we can factor the x squared minus 1 into x plus 1, x minus 1. And since we're squaring that, that happens twice. So x plus 1, x minus 1. All the x plus 1's cancel each other out, and we're left with negative 3 over x minus 1 squared. All right, so similar to the product rule, there's a very, very valuable lesson that we must learn when we are introduced to quotient rule. The box below, first factor and simplify the function that we worked on above, then differentiate using quotient rule. So let's first factor f of x. So f of x factored gives us x plus x plus 2, x plus 1 over x plus 1, x minus 1. The x plus 1's will cancel out, so we're left with x plus 2 over x minus 1. So when we find the derivative of that using the quotient rule, here's my high function, there's my ho function. So we get ho d high, which is x minus 1, derivative of my high function is 1, minus high d ho, x plus 2, derivative of my ho function is 1, all over x minus 1 squared. So I get x minus 1 minus x minus 2 over x minus 1 squared. The x's cancel on the numerator, so we're left with negative 3 x minus 1 squared. So the lesson to be learned from what we did above is that if you can factor and simplify first, because it'll just make the quotient rule a lot less messy. So if you can factor and simplify first, do so. So now we're going to use the quotient rule to derive the derivative formulas for the remaining trig functions. So we looked at cosine and sine, but we never looked at tangent or cotangent or secant or cosecant. So now we're going to look at how we would find the derivative for those things using the quotient rule. So we know that from the quotient identity, we can rewrite tangent as sine theta over cosine theta. So we're going to use that to help us differentiate tangent. So that means that the derivative of f of theta, using the quotient rule, sine will be my high function, cosine will be my whole function. So we get ho d high, so cosine theta, the derivative of sine, which is cosine, minus high d ho, so sine and the derivative of cosine is negative sine, all over ho ho, so cosine squared theta. So when we do this out, we get cosine squared theta plus sine squared theta all over cosine squared theta. And we know that cosine squared theta plus sine squared theta is a trig identity. That gives us 1. And we're 1 over cosine squared theta. 1 over cosine is secant, so 1 over cosine squared must be secant squared theta. So we've just found out that the derivative d dx of tangent theta equals secant squared theta. So we just proved the derivative of tangent. Okay, I'm going to leave you to prove the derivative of cotangent, and I'm going to move on to prove the derivative of secant. So secant, we know, can be rewritten as 1 over cosine theta. So then, using quotient rule, f prime of theta, if 1 is my high function, cosine is my whole function, then I have ho d high, which is cosine theta, derivative of 1 is 0, because 1 is a constant, minus high d ho, so 1, and then the derivative of cosine is negative sine theta, all over ho ho, so cosine squared theta. So cosine theta times 0 is 0, so we get positive sine theta over cosine squared theta. Which we can rewrite by separating the fractions into sine theta over cosine times 1 over cosine. So sine over cosine is tangent, and 1 over cosine is secant. So the derivative of secant theta is equal to tangent theta secant theta. So we've just proved 2 more trig derivatives. You are going to use this time now to prove cotangent and cosecant. Figure out what their derivatives are. I'm also going to leave you to figure out the derivatives of the bottom 2 functions, f of x and p of theta. What we're going to do now is move on to the next page, where you're asked to find sine theta over 1 minus cosine theta, the derivative of that, and the derivative of this f of x complex fraction. So we're going to start with h prime, which h of theta. So we have our high function is sine, our whole function is 1 minus cosine. So h prime of theta should be Hody high. So 1 minus cosine theta, derivative of sine is cosine, minus high d ho, so sine theta, derivative of 1 minus cosine will be positive sine all over ho ho. So 1 minus cosine theta squared. So now simplification. So we have cosine theta minus cosine squared theta minus sine squared theta all over 1 minus cosine, oops, forgot theta. The next step, we can factor out a -1 from the negative cosine squared minus sine squared. So we get cosine theta minus 1 times cosine squared theta plus sine squared theta. The reason we did that is because we have an identity for cosine squared theta plus sine squared theta. So we need that. All over 1 minus cosine theta squared. So using that identity, this cosine squared theta plus sine squared theta turns into 1, and 1 times -1 is just going to stay -1. So we'll have cosine theta minus 1 over 1 minus cosine theta squared. Okay. So for the numerator, we can rewrite the numerator as -1 plus cosine theta over 1 minus cosine theta squared. And to get -1 plus cosine theta to look like 1 minus cosine theta, we have to factor out a -1. So we have a -1 on the outside, and on the inside we have 1 minus a -1, and then 1 minus cosine theta on the numerator, all over 1 minus cosine theta squared in the denominator. You can cancel out one of those. So our final answer is -1 over 1 minus cosine theta. All right, and now for this mixed fraction. Great thing about this mixed fraction is we can rewrite it in our first step. So in order to rewrite this mixed fraction, we need to first combine our like terms in combine our fraction in the numerator. So we have 3 over 1 minus 1 over x, and that'll give me, in order to combine these, we need common denominators, right? So I'll have 3x minus 1 over x, that's my numerator, all over x plus 5. Now to divide fractions, we know we keep, change, flip, right? So this is equal to 3x minus 1 over x times 1 over x plus 5. So f of x is actually 3x minus 1 over x squared plus 5x. So our high function is 3x minus 1. Our whole function is x squared plus 5x. So f prime equals Hody high. So we have x squared plus 5x. Derivative of 3x minus 1 is just 3 minus high d ho, so 3x minus 1. Derivative of x squared plus 5 is 2x plus 5 all over x squared plus 5x squared. When we multiply this all out, we get f prime of x equal to 3x squared plus 15x minus 6x squared minus 13x plus 5 all over x squared plus 5x squared. So f prime of x equals negative 3x squared plus 2x plus 5 over x squared plus 5x squared. Okay, so below is a graph of the function f of x, and we're going to let r of x equal cosine x over f of x. We want to know if the graph of r of x increasing, decreasing, or neither increasing nor decreasing at x equals pi. I want to show our work and justify our reasoning. So this graph is of f of x. And we know that r of x is equal to cosine of x over f of x. Luckily, in this problem, we're not looking for an actual value. We're just looking to see if it's increasing or decreasing or neither. So, in order to determine that, we need to first find r prime of x, the derivative. So, if cosine of x is our high and f of x is our ho, then we know we have ho d high, so f of x. Derivative of cosine is negative sine x minus high d ho, so cosine x. And then we'll find the derivative of f of x all over f of x squared. So since we want r prime of pi, we'll plug that in. So we get negative f of pi sine of pi minus cosine of pi f prime of pi all over f of pi squared. So the reason why I said that this problem is a little nice because it's not asking us for a value is because since we're only looking for increasing and decreasing, all we care about are the signs of these values, right? So we'll have negative, and then f of pi is about 3.14. So f of pi is a negative number. Sine of pi is 0 minus cosine of pi, which is a negative number, times f prime of pi. So f prime again is the slope. So our slope of this line is going to be a negative number all over f of pi, which we said was negative, squared. When we put all that together, a negative times 0 is 0, minus negative times a negative is a positive, all over a negative squared, which is positive. So we get 0 minus a number, positive number, which is the negative number, all over some positive number. So final answer is a negative number, which means that since r prime of theta is less than zero, r of pi is decreasing. All right, and now we're going to move on to the last page, page 84. So on page 84, we have a table of values for x, f of x, g of x, f prime of x, and g prime of x, and we need to figure out these different values. We're going to use quotient rule when needed. We're going to use everything that we've learned so far when needed. Okay, so for the first one, we're just asked to estimate the value of the derivative of 2.5. So if we're estimating and we're given a table, we're just going to use the slope formula. So 2.5 is between 2 and 3. So we'll do p prime of 2.5 will approximately be equal to the slope of between 2 and x equals 2 and x equals 3. So we'll look for g of 3 minus g of 2 over 3 minus 2. That's approximately going to be equal to g of 3 is negative 3 minus g of 2, which is negative 1, all over 1. So negative 3 plus 1 is negative 2. So we're approximately going to be negative 2. All right, so the next problem says if p of x equals g of x over f of x, what is the value of p prime of 4? So to do that, we're going to need to know what p prime is going to be equal to. So our high function is g of x. Our whole function is f of x. So p prime of x should be equal to quotient high, so f of x, g prime of x, minus high d ho, so g of x, f prime of x, all over ho ho, so f of x squared. And since we're looking for p prime of 4, plug in 4, we'll get f of 4, g prime of 4, minus g of 4, f prime of 4, all over f of 4 squared. You plug in all those numbers, we'll get negative 58. Now, what does that value tell you about the graph of p of x when x equals 4? Since p prime of 4 is less than 0, then p of x is decreasing at x equals 4. All right. I'm going to do q of x with you, and I'm going to leave you to do v of x on your own. So q of x says 2x squared times f of x over g of x. What is the value of q prime of 2? So this problem is a combination of both product and quotient rule. Okay, so we have product rule here with the 2x squared and the f of x, g of x. We're multiplying those two things. All right, so product rule tells us that we take the derivative of the first value, so that's 4x, keep the second, f of x, g of x, and then we add the first function, which is 2x squared, and the derivative of the second function. So the derivative of the second function is now where we're going to use quotient rule. We've already found it in the previous problem, so I'm just going to rewrite it. It was f of x g prime of x minus g of x f prime of x all over f of x squared. Oh, wait, I made a mistake. That was not the same problem as above. Above we had g of x over f of x. This is f of x over g of x, so we will need to rewrite this. So this is OD high, so g of x, derivative of the numerator, so f prime of x, minus id ho, so f of x, g prime of x, all over the denominator squared, so g of x squared. Sorry about that. So now we want q prime of 2. So we'll plug in 2 everywhere we see x. So we have 4 times 2 times f of 2 over g of 2 plus 2 times 2 squared times g of 2 f prime of 2 minus f of 2 g prime of 2 all over g of 2 squared. And that brings us to negative 16 plus 8 times negative 7 brings us to negative 72. Right? So the last problem asks you to find the equation of a line tangent to the graph of v of x equaling 3x over g of x when x equals 3. So you'll use the quotient rule there, find your derivative, plug in to find your SOT, figure out your POT, write your equation. So do that one problem on your own.